Alright, so we'll begin today's lesson. I'm assuming for the others who are not here, they may have network issues or just haven't tried to join yet. If you can reach out to your friends, tell them to try to join in quickly. Yeah, but we'll begin now. It's been a week without activity, so I'd understand if some things are a bit foggy, of course. So I'd like to know if you guys would need to do a brief recap, or we can go forward today. Would you guys need to do a brief recap before we begin today's lesson?
Yes.
Okay. In that case, I'll pass it back to you guys. I'm assuming you've been taking notes or reading through the summarized notes, so I'll ask for a bit of a summary from you. But before we do so, I would like to apologize. An apology isn't really necessary because I was sick. However, a whole week of inactivity set us back by quite a long period of time, and we may not finish as quickly as we could have. However, I was unable to come through. I was very sick, I should say. I haven't been that sick in a while, but I am hoping that we'll be able to still make sufficient progress within the given period of time, and perhaps a bit earlier. As always, my main goal is for you to understand, for you to clearly grasp basic concepts about this issue, so when you come here and you have to deal with the material, it's not too difficult for you. Alright, so Priscilla's left. I'm assuming it's a network issue. So, can anyone give a brief summary of what you remember from perhaps what you've looked at this week? Because if I were to give a summary of everything, it would be a bit too much, considering you had about 3 lessons. So, anything you might remember, any important points? If not so, perhaps I might ask you, do you guys have any questions concerning what we learned? Any clarifications that you might need? Instead of that, we can either do a recap, or you can ask me specific questions where you didn't get it.
I have a question.
Go ahead, Naomi.
On the last topic we did, the second law, we talked about the complementary goods, independent goods. Like, where was all this coming from? I didn't understand where all this was coming from.
Where it was coming. Alright, let me share my screen first. Then we'll go about answering that. So that would require me to go to the previous lesson then. In a lesson before, someone had asked me if it was possible to pass along questions to other students. Would you still like to do that? And if so, does someone want to answer this question?
What was the question again?
Naomi, please repeat your question.
I was asking, in the previous lesson, we looked at like different types of goods. Looked at the independent goods, the complementary goods, and the something like that. Yes. So I'm asking, where did this whole thing come from for us to start looking at the goods? How did it come about?
Would anyone like to answer that? Is anyone willing? Anyone ready? No one? Alright, so first of all, are you able to see the screen? Can you see the presentation?
Yes.
Yes.
Okay. So, starting from the first part, the first page of our presentation, I begin to give you a summary of what this law means. So, to briefly recap that, the law of equalization of weighted marginal utilities rests on the idea of the fact that you can add utilities, that you can combine satisfaction to give you a bigger satisfaction based on two different goods. So it's a case where you're considering different goods and you are adding their utilities. Now, on this part, we saw a pretty important word, the independence of goods, telling us that there are some goods that are independent. Now, the reason I gave you different types of goods was for you to understand the difference. There are three different types of goods that you can handle. You have independent goods, substitutable, and complementary goods. And so I just wanted you to understand the difference amongst these three. Of course, we will be focusing specifically on independent goods, but I needed you to understand the difference between the three. Firstly, for your knowledge, and then in case you look at something similar later. Does that make sense?
Yes, it does.
Alright. If that's answered, any other questions that I might have to handle? Any clarifications? Or would someone like to give a summary of this particular lesson, what you remember from this lesson?
As in since day one, or maybe just the previous lesson?
Just the previous lesson. Unless you want to start from day one, I'm fine with that. At least one person, and then we can begin today's lesson. This is worrisome. Saber, you seem to want to speak.
Alright. I'll talk about Alex.
Go ahead, Alex.
Alright. I'll talk about substitutable goods and the complementary goods.
Alright.
Substitutable goods aren't about there are types of goods which are interchangeable. And a consumer can buy more of the other and less of the other, but the satisfaction will be the same. Then we also looked at complementary goods, where can't buy the other without the other. Like if you buy a phone, there's everything in that phone. There's a charger, the headsets, everything. So you can't buy one without the other. It's like they go together. I think I'm right. I don't know. We also looked at independent goods. I think I said I would just say about the substitutable goods and the complementary goods. That's all.
Okay. Yeah, right about the two goods. You're fine. Thank you, Alex. So that's a pretty good summary of the two. Anyone else?
Yes, just want to talk about the first part. So first of all, we started by looking at what microeconomics is, and then we defined microeconomics as just a branch of economics, which deals with the study of behavior of rational individuals. They're not only that, but these rational individuals, they are provided with goods, and then from these goods they have to choose the goods which give them the most satisfaction, and then this most satisfaction or this choice that they make by choosing the goods with most satisfaction is known as the optimal choice, or the poor optimal. Not only that, but we also looked at total utility, which is just the aggregate of the satisfaction which one gets from using a specific type of good or service. Not only that, but we also looked at equilibrium, which is just the balance between the usefulness of a good and the cost of that same good. And then we also moved on to look at the poor optima, which is we also looked on to look at the poor dosatiete, which is just the maximum point of the marginal utility, and then from there it starts to decrease. And then there are also two laws of quotient, which is that one for decrescent, marginal decrescent, and then there's also that one for equalization, the law of equalization. So yeah, basically that.
Okay. That's a very good summary. Thank you. That was Xavier speaking, no?
Yes.
Okay.
Sure.
Thank you. Yeah, so I think that pretty much very much summarized what we've done so far. I still believe that people may have questions. For those who have questions, you're free to come to my DM and I can clarify as much as possible. One thing to note definitely is that you won't understand everything during these courses. In as much as I wish that you would understand everything, you may not. But that's fine. The little you understand will go a long way and it will make a difference where you're going. And so I'm happy to know that you guys have been paying attention. Of course, I'm certain that not everyone's at the same level, but I know that everyone is learning something here and there, and you will learn more with time. So today we are moving to the next section of our chapter. We'll be looking at ordinal utility. So I'd like to confirm, are you able to see my screen? Can you see the presentation?
Yes.
Okay. I thought I'd change the look up a bit as well. The colors and everything, because it's a whole different section. So, in starting a new section, it's important to understand the basis of the first section. So, Alex, you should start my time now.
Alright.
Alright. So, the whole idea of marginal utility, it's the theory that you can quantify something like satisfaction. That's to say, you can measure how satisfied someone is with a good and put it into numbers. Now, for ordinal utility, we're going to see something quite different actually, because people who came up with these theories are different people, and they had different thoughts about the ideas of satisfaction and utility and all of that. So our first slide. According to the approach of ordinal utility, il est impossible de quantifier un phénomène aussi subjectif que la satisfaction ou l'utilité. So, the people who came up with this particular theory said it is impossible to quantify a phenomenon as subjective as satisfaction or utility. Like, it's impossible to put into numbers how satisfied someone is with a good. So the question is, if you won't put it into numbers, how exactly are you going to measure how satisfied someone is? And that takes us to our next slide. According to this approach, the rational consumer simply has to establish an order of preference through classification and comparison of goods. That's our first point here. The consumer simply has to create an order of preference by classifying and comparing goods without measuring utilité, sans mesurer utilité. So this is a case where you won't be dealing with total utility anymore. You won't see it. You may see it pointed out, alluded to, but you won't necessarily have to see any numbers. You will, however, see marginal utility, and you will see why that is. Are we together so far?
Yes, but last time we said to say under cardinal utility there are two utilities, which are marginal utility and total utility. But where is this ordinal utility coming from?
Ordinal utility is the next section. So here's how the flow of things is. In this first chapter, we'll be studying utility. So
is it also under cardinal utility?
No, it isn't. It's its own thing.
For sure thing.
Yeah. So like I was saying, we will be studying utility. The first part is cardinal utility, and then that's everything that we saw in the other week. And then this week we'll be looking at ordinal utility, which has different theories attached to it. Later we'll see other things. But in terms of utility, it's these two main branches, cardinal utility and ordinal utility. Is that clear?
Yes, it is. Thank you.
You're welcome. So in that case, I will try to specify that in the previous slide. I'll try to add it in the first slide, rather. On marginal utility, I'll clarify that it's only a section. But yeah, for now, I hope this part is understood. So our next line here tells us that in the same way as we were looking at the approach of cardinal utility, celle de l'utilité ordinale adopte aussi le théorème d'égalisation des utilités marginales pondérées. That's to say that even in this case, we'll still be looking at the second law of Gaussian. We'll still be using that law as we go on, as we study ordinal utility. Is that okay?
Yes, it is.
Alright. So, under ordinal utility, we're going to look at a couple of things, a couple of important things. The first one is la carte d'indifference. The first one here. And then later, we'll be looking at le courbe d'indifference. And finally, le taux marginal de substitution. You'll see that these second ones, the curves, le courbe, they are under the cart. It's like shall I say a table, but you'll see as we go along. But these are 3 things that we'll look at in this lesson and that are particularly important. So, we'll start with la carte d'indifférence. Elle présente toutes les préférences d'un consommateur à travers un ensemble de courbes d'indifférence. Elle se constitue d'un ensemble de courbes d'indifférence. I had to make this clarification so it's pretty simple. The carte d'indifférence is just a compilation of curves of indifference, courbe d'indifférence. We'll see that definition in the next slide, but just keep note of this one. An easy way to remember exactly what la carte d'indifférence is all about, just know that it's a compilation, it's an amalgamation of curves of indifference. Is that okay?
No, kindly explain that again.
Do you see this table here? This graph, so to speak? Are you able to see it?
Yes.
Okay. So this entire thing is what we call la carte d'indifférence. And then these lines going this direction are what we call curves of indifference. So when I say that la carte d'indifférence is an amalgamation or a combination or a compilation of curves of indifference, just tells you that these are the things that make up the carte d'indifférence. These are the things that you'll find there. If someone asks you what la carte d'indifférence means or what it is, they tell you it's just a combination of curves of indifference. And I'm about to explain what these curves of indifference are. Fine? Do you still need clarification?
No.
Alright. So, before I give you the definition of an indifference curve or a curve of indifference, a courbe d'indifférence, there's something I want you to understand that will lead us to that point. So, in the first slide, we mentioned that the consumer will not measure utility because according to this theory it's impossible to put it into numbers. However, the consumer will set up preferences by comparing goods and putting them in categories. And so this slide explains how the consumer will do that. So what the consumer will do is that they will come up with combinations of the good X and the good Y. Remember that we're looking at 2 goods now. So the consumer will combine these goods and assign to each of these groups an indice of utility. That's our first point. Le consommateur compose de groupes de combinaisons X, X et Y et affecte à chacun de ces groupes un indice d'utilité, U1, U2. So basically they'll say maybe X is some medicine and Y is a type of drink. We put them together and say this is our first group, this is U1. Then they'll say maybe a different kind of medicine, maybe of a higher grade, and another kind of juice, this is our group 2, we say it's U2, U3, U4, so on. It's basically just goods grouped together and given a name, U1, U2, U3, going forward. Is that fine?
Yes.
Alright, thank you. So, our second point. À l'intérieur d'un groupe, les différentes combinaisons XY procurent un même niveau de satisfaction et sont and C equivalent. That's to say that you will have different combinations within one group, but each of these combinations has the same level of satisfaction. Say I have a medicine, I have Brufen and a particular drink, and then in the same group I have something called Doliprane and another kind of drink. They're different goods, but they give us the same satisfaction. That's why they're in one group. If they didn't give us the same satisfaction, they would be in different groups. Is that point clear?
Yeah, maybe you can repeat on that one.
Alright, no problem. So let's take one on this U1, right? In this, under this name, rather, we have different combinations of goods, X and Y. You could have a number of them, 3, 4 different combinations, but they are in one group because they have the same level of satisfaction. Like, it doesn't matter which one of these combinations you choose to take, they give you the same satisfaction. I was giving the example previously of medicine in a particular drink. Why I chose this, because usually most people don't take medicine without something to drink. Usually it's water. Of course, other people don't use water because medicine is gross. I'm one of those people. Anyway, so you have different combinations, medicine and a particular drink. So you could have maybe 3 different combinations, 3 different types of medicine and 3 different types of groups of drinks rather that you add to them. But they're in one group because they give you the same amount of satisfaction. That's why they're under U1. How can I make this more practical? Of course, I'd need to assign it a number, but they give you a particular level of satisfaction, each of them. When you go to U2, you find that you have different combinations again, but the satisfaction is different. That's why they're in different groups. Let me try to do something here. Do confirm if you can still see.
Yes, we can see.
Okay. So say you have this group, U1. In this group you have Doliprane C and drink 1. So that's one combination. Then you have Doliprane and drink 2. Let's say you have Brufen and drink 3. So this here is one group, and all of these 3 different combinations will give you the same level of satisfaction, and so they're under U1. Then you could have U2, have different combinations here. You have Brewston, drink 4, do that. You have Panadol. And drink 5, and so on. You have different combinations. What differentiates U1 and U2 is the fact that the satisfaction that you procure from these is different, and particularly the fact that the ones in U2 give you more satisfaction. So if you're presented with the groups in U1 and in U2, usually you pick anything that's in U2 because it gives you a higher satisfaction. So basically the consumer makes a group of combinations and says, okay, these ones give me the same satisfaction, they'll be in U1. Another group, these ones give me the same satisfaction, they'll be in U2, U3, U4, going forward, until they find the highest. Is that okay?
Yes, but what if we had U3? Which one would give us the most satisfaction?
U3
again.
Voila. It's always the higher one. And that question brings us to our point here, our last point here. It says that the indices of utility are classified in an increasing order. That's to say that U1 is lesser than U2, U2 is lesser than U3, U3 is lesser than U4. For example, pour U1 et U2, le consommateur préfère n'importe quelle combinaison du groupe 2 à chacune des combinaisons du groupe 1. That's to say that the consumer will pick anything that's in U2 over anything that's in U1 simply because it's greater. Are we clear?
We.
Okay.
Oui.
I'm only hearing the guys responding. The girls, are we okay?
Oui.
Yes.
D'accord. Alright, thank you. Right, so after understanding how the consumer sets up their preferences, it therefore brings us to the definition of a curve of indifference, an indifference curve. La courbe d'indifférence est le lieu géométrique des points qui représentent toutes les combinaisons possibles de biens X et Y qui donnent un même niveau d'utilité, ou plutôt un ordre d'utilité identique. That's to say, I showed you those particular lines. So those lines, the coordinates for those lines are combinations of goods. And so basically, a curve of indifference is a visual representation of an index of utility. I'm sorry. I'll say that again. A curve of indifference is a visual representation of an index of utility. So I'll come back to a word here. This is an index of utility. One group is an index of utility. And then when you put it on a graph, it becomes that line because you have your doliprane C as X and drink 1 as Y. That means you're going to have coordinates on your graph, and then it will give you something of this nature. So this curve just shows you every possible combination of goods that you can have that give you a specific level of utility or level of satisfaction. That's why I said previously that if a particular combination of goods has a different level of satisfaction, it can't be in the group with the others. You can't have, in this case, let's say you can't have Brewston and drink 4 in the same group as Codoliprane and drink 2 because it gives you a different satisfaction. Anything I need to clarify so far?
No,
Kind of.
and it is.
Wait, hold on.
It's not that clear.
All right.
Kindly go back to the previous slide and explain that, that point there.
Which slide would that be? This one? Or
No.
here?
Yes.
Probably the best way to properly explain this would be to show with numbers how the graph looks. But in that case, we'd be getting ahead of ourselves. But well, let's see what works best for you to properly understand. Alex, how much time do I have?
Yeah, I wanted to tell you that it was time up, but yeah, she came in.
Okay. So what we'll do is I will go on our break for now, and then we will come back and start with that question. Yeah? Alex, you tell me when to come back.
Nous pouvons commencer, madame.
Okay, thank you. I'm asking for about 5 more minutes or something I need to handle here. So yeah, in that time, just go over whatever note you may have taken so far. I just need to handle something here. Just about 5 minutes more. Do pardon me for the delay. Are we there?
Yes.
Yes.
Savior, you're lost. I'm reading the chat. Okay. I will try to explain that a little bit better. Like I said at the beginning of the lesson, you may not understand everything at one go, but you will with time. So don't worry about that too much. Alright, so I'll share my screen again. Do confirm that you can see.
Yes, we can see.
Yes.
Alright. So we'll start this part again. The definition of a curve of indifference. An indifference curve. Like it says here, it's a geometric line of points. That's why it's a particular curve. I know that graph is very confusing. If I had drawn it myself, I would have highlighted it, but unfortunately I just copied it and put it there. But it's a geometric line of points, and it shows you every possible combination you could have of your goods, X and Y. In this case, we're looking at medicine and a particular kind of drink. So every possible combination of those things that gives you the same utility or satisfaction is what we call an indifference curve. And like I said, it would look something like this. Let's take U3, that's alone. Ignore everything else and just look at U3. But perhaps that might make it easier. So here we have our U3. For it to come to this sort of shape, you have to have different coordinates, different values of X and of Y, and it will show you this point. As we go on, you will see how exactly it's formed, but for now, just understand that this is what it's supposed to look like, and it's only because it's a combination of the goods that gives you a particular amount of satisfaction. That's all you need to understand for now. So in that case, is it to some degree clear?
Yes, so like you
Yes.
said, to state la carte and difference, just the amalgamation of different curves, isn't it?
Exactly.
Yes, so is it right to say those things which make up the la carte and difference, they are the la cube and difference,
Exactly.
like the unit?
Yeah, you're right. It's fine. We can go on.
Yes, thank you.
Okay. Okay, let me just eliminate this. Okay. So we'll come back. And we'll come here. So this particular point here is very important. You may not handle it as a question or anything in your exams, but it's just something to keep at the back of your head. So it says, la carte indifférente représente un niveau variable de satisfaction, alors que la courbe d'indifférence représente un niveau constant d'utilité. I remember in the course of our previous lessons, I mentioned that the words satisfaction and utility can be interchanged, so that's why you see that difference here. It basically saying, talking about the same thing, rather. So the first point tells us that the carte d'indifférence shows us a variable level of satisfaction. That's simply because you have different indifference curves in it. because you have so many, you're observing so many, you will see different levels of satisfaction. The very fact that you have U1, U2, U3, and going forward just tells you that you are looking at things that show you different levels of satisfaction. However, the curves of indifference themselves show you a constant level of utility, which is what we previously discussed. The fact that within this group, you have different combinations, but they all give you the same utility. So what am I trying to say? Let me try to break that down into one or two phrases. When you observe the entire Cardinal difference, you're observing different levels of satisfaction because you have different indices, that is U1, U2, U3. But when you go into the curves themselves, when you study just U1 itself, you're looking at something that will show you a constant level of utility because the groups inside there only give you a specific level of utility. Is that okay?
Oui.
Okay, thank you. Today we're going to do theory mostly, and we'll do the application in our next lesson. So the next point is this slide here. Again, no need to worry about the entire thing. What we're looking at here is the characteristics of these indifference curves. How would you know that you're looking at an indifference curve? If I gave you a particular graph without any notation, how would you know that you're looking at an indifference curve? So the first point tells us that plus une courbe est éloignée de l'origine, plus le niveau de satisfaction qu'elle traduit est élevé. This just brings us back to the point that we mentioned previously that tells us that U1 is lesser than U2 and U2 is lesser than U3. The point tells us that the more a curve is éloigné in English, the more a curve is extended from the origin point, which in this case is 0, the further it is from this point 0, the more the satisfaction you're looking at. That's to say that because in the graph we're looking at here, because U3 is the farthest from 0, it is the index that gives you the most satisfaction. Clarifications there. I'll go through it again, but do you need clarifications? Questions?
Yes, since we're saying to say U3 is the one which will give us the most satisfaction, but are we not considering the issue of the budget, or maybe there is nothing like the constraints of our budget?
The budget is being considered. We'll see that at a later stage. It's the part that follows this section. But for now, just focus on this. Eventually we'll put them together, yes, but for now we just focus here. Alright, any other questions before I go through that part again? Alright, if there's nothing, I'll say it again. The first characteristic of an indifference curve is that the farther it is from the point of origin, the higher the level of satisfaction that it translates or that it tells you it has. That's to say that U3 is greater than U2 and U2 is greater than U1. And then the next point on the same thing here is that the consumer always prefers the indifference curve that is the farthest from the origin. Le consommateur préfère toujours la courbe d'indifférence la plus éloignée de l'origine. That means that the consumer will, in this case, always choose U3. I hope that's clear. If not, you can stop me. The next characteristics is that two indifference curves will never cross each other. Deux courbes d'indifférence ne peuvent jamais se couper. As you can see from the graph, U1, U2, U3, they never touch. They are going in a similar direction, but they never touch each other and they never cross each other. Now, why is this important? The next point is that si deux courbes se coupaient, deux niveaux différents d'utilité correspondaient à une même combinaison, ce qui est impossible. So, if for example U1 and U2 were to meet at some point, it would mean that a particular combination in U2 and in U1 give us the same level of satisfaction. But then that's not possible, because we mentioned previously that for them to be in different groups, it means that they have different satisfactions. Is that point clear?
Maybe you can just repeat on that one.
Sure, no problem. So it says again, two indifference curves can never cross each other. Deux courbes d'indifférence ne peuvent jamais se couper. If they were to cross each other, it would mean that the combinations, or a certain combination within these two curves, gives you the same satisfaction. So we'll come back to this example I gave previously, where we have Doliprane, Codoliprane, Brufen, and then we have Brustan, Panadol with their corresponding drinks. So, if for example the curves U1 and U2, for some reason, we're assuming, met somewhere, say excuse me, say they met at the point where you find Brufen and drink 3 and Panadol and drink 5, you find that they're at the same point. It would mean that you now have two combinations from two different groups that give you the same satisfaction. But that's something that's not possible, because for them to be in different groups, it means that they give you different levels of satisfaction. Let me try something here. I want to show it graphically to some degree. Just need to write something, but before I do, is that part clear to anyone? Or is everyone a bit lost there? Guys, Muliko? No, we're okay.
Yes, I think on my part, I've understood the point you've said. Two different caves never touch or cross each other.
Mm-hmm.
But you said if they were to cross each other, it will mean that
a particular combination of goods will give you the same satisfaction. That is goods from different groups, that is. Hold on, I want to show something. How best can I? For those for whom it's clear, that's good. Probably, if it still isn't clear to this point, you can always ask each other after class. Yeah. Alright, so we have the same figure here. Now say we were to redraw this thing, and say you have U1 here and U2 here. We're assuming this is possible, but it isn't. So at this point here, where they've met, you have two different combinations of goods. Say in U2 you have X2 and x1, and in u1 you have x1. What did I just do? Hold on. y1, y2. Voila. x2 and y2. And then in u1 you have x1 and y1. So if these two meet at one point and yet they're in different groups, it means that they give you the same level of satisfaction. Let's assume we're using numbers here and say that this gives you a satisfaction of 5 and this also gives you a satisfaction of 5. But considering what we said before, that you can't have different satisfactions in different groups, it wouldn't make sense, because let's say that in u1 every single combination you have gives you a satisfaction of 5, but then in u2 every single combination you have should give you a satisfaction of 7 because it's higher. How possible then would it be for you to have a combination in u2 that gives you a satisfaction of 5? It's not possible. But then saying that these two could meet here is like saying that in a group where everything is equal to 7, you have one combination that's equal to 5. In that case, it's not possible. So that's why curves can never cross each other. It implies a lot of really complicated things that wouldn't make sense according to our theory. I don't know if I've confused you more or if I've helped to help you to understand a bit more.
I think it's clear.
Okay. Alright.
It's clear, it's clear.
It's clear.
Okay. Thank you very much, everyone. Okay. So we'll come out of here. I'll leave this open in case we have to come back. Voila. Okay. So we'll go at it again. The first point: the further a curve is from the origin, the higher the level of satisfaction. Second point: two curves can never cross each other because it implies that you can have combinations within two different groups that give you the same satisfaction. However, that's impossible. And then the last point, which is the simplest, is that the indifference curves are decreasing. Sorry, French. The shape of an indifference curve is in a decreasing fashion. Let me breathe first. Okay. So, the shape of an indifference curve is in a decreasing fashion and has a convex shape. I believe you guys remember the implication of the word convex from physics, something to do with mirrors and light and whatever. But this shape here, the fact that it's first of all going downwards, and in this particular shape is what will show you that you're looking at an indifference curve. It's just talking about what how it's shaped rather. So yeah, that's it. Are we free to go forward?
Yes, but talking of curves,
Yes.
two curves just as in U1 and U2, or maybe it's over.
Repeat the question again.
Yes, as in talking of curves, is it possible to have two curves as in U1 and U2, or maybe it's always up to you, or you can even extend it to
You can extend. It's unlimited. It depends on the consumer. It depends on it's unlimited.
1 minute.
1 minute left.
Yes.
All right. Yeah. So for this part, we're done. We'll be moving to the next part. So coming back to our first slide, our goal today is to look at the carte d'indifférence, le coupe d'indifférence, et le taux marginal de substitution. So far we've looked at these first two, and when we come back from the break, we'll go into the next part, and after that, we will be done. Like I said, just theory today. So, yeah, I guess we'll go on our break, and Alex, you tell me when to come back. While we're on break, take time to think over what we've learned so far. Think about it. Think about any points where you aren't really clear, any points you might need clarification, or you just need to go and study it a bit for yourselves. Just think it through, and then we'll come back when Alex tells us to.
can start, madam.
Thank you, Alex. Alright. Let me share my screen again. Okay. So, before we go to the second part of our lesson, is there anything I need to clarify from what we've touched on so far? Everything's okay?
Yes.
Alright. Thank you. So, now, the second section and the very last part we'll look at today is le taux marginal de substitution de biens, the marginal rate of substitution of goods. So in this case, we're still considering two goods, X and Y. We're now considering possibilities of substituting these goods one for the other, but in a way that we still have the same level of satisfaction. Say the consumer has measured their preferences and they've chosen U3 being the highest one, and they've chosen a combination within U3. Now the consumer is considering the goods at their disposal and they're wondering how can I have more of X and less of Y but still have the same satisfaction, and that's what we'll look at in this case. So le taux marginal de substitution de X à Y mesure la quantité de X que le consommateur est prêt à céder contre une unité supplémentaire de X, tout en conservant le même niveau de satisfaction. So the marginal rate of substitution measures the quantity of X that the consumer is ready to give away against a supplementary unit of X. So in this particular case, we're looking specifically at you're losing Y to gain X. It can be the other way around, but in this specific case, we're looking at X and Y. So the consumer is trying to see how much can I give away of Y to have another unit of X and still have the same satisfaction. We'll move on. Is that clear as we go on? Someone has a question. Should I go again?
Yes.
Towards in X and Y, they're both good.
Exactly. Yeah. So let's go back to our Word document. So in this example, say our consumer picks U2, right? And then maybe the consumer picks this first option here, Brewston and drink 4. We know already that this group gives us the same satisfaction. Let's say that Brewston is X. Brewston will be our good X, and drink 4 will be our good Y. So when we're looking at the marginal rate of substitution, the consumer is trying to look at how much of drink 4 can I give away, and to gain more of good X or Brewston and still be within this level. Let's say again it's 7. Excuse me. Say for example you buy about 5 bottles of drink 4, 5 bottles, and then you get 6 packets of Brewston. So this is your first combination generally. What this person wants to see is, maybe I can have less of drink 4. Maybe I can get 3 of them and then increase Burstan just to 7, and it will still give me the same satisfaction. We're trying to measure how much can this consumer trade Y, how much can you lose of Y and gain X and still have the same satisfaction within the same combination. Is that clear?
Yes.
Okay. Thank you. I'll repeat this as I always do. If I am giving an example and I still confuse you to a degree, don't hesitate to tell me, and I'll try to explain it further. But yeah, as this first point says, the marginal rate of substitution measures the quantity of Y that the consumer is ready to give away against, or in order to gain, a supplementary unit of X, tout en conservant le même niveau de satisfaction. So you're losing some of Y and gaining some of X, but you still have the same satisfaction. So what we have here is just the formula for calculating this rate of substitution. There's 2 different conditions. There's this formula here and another formula here, but we'll look at this in stages. So there's different ways you can come to this depending on the information that you have, but for now we'll stay here. So this point tells us that si les biens X et Y ne sont pas parfaitement divisibles, on mesure le TMS entre 2 points d'une courbe d'indifference. Entre le point A, X1 et Y1 et B, X2 et Y2 de la courbe U1. So this is something I'll give you as a research point. I want you to go and research the meaning of a perfectly divisible good and an imperfectly divisible good and see what that means for you to understand this point here. I'll send you a small document showing you exactly what to search, and I would recommend that you do it in French instead of English, and it will help you to understand it more in French. So this particular formula is in a case where you have goods that are perfectly divisible. This is the formula that you would use. I won't explain much here because I want you to go and research what this means, but just take note of this formula. It will be important as we go on. So the formula is TMS of X and Y of X to Y is the negative of the variation of Y over the variation of X. This is a minus here. This is very important, so just keep that in mind. Like I said, not much to explain, just take note of the formula because you'll use it as we go on. Anything to clarify as I go to my next slide?
After the equal sign, is there a minus again?
Yes, there is. One thing to take note of, whenever you see these triangles here, it just means variation. I believe I mentioned this before. So this last point here, it's the same thing you're seeing here. It's just that it's now, in the first point it was just expanded. So after the equal sign you have a negative, and then you have this fraction here, y2 minus y1 over x2 minus x1. This is in a case where you're dealing with the curve u1. This first line here, you have x1 and y1 and x2 and y2 that meet here. So it can be y3 minus y y2 over x3 minus x2. It all depends on the information that you're given, but this is the general look of this formula. Is that okay? We'll see this more practically as we go on, of course. For now, just keep it in mind. Okay, so we'll go on. This next slide just gives us information about the progression of the TMS in terms of its values. It tells us, à partir de cette formule, on constate que le TMS XY décroît à mesure qu'on substitue X à Y. That tells us that the more that you are substituting Y for X, the more you lose Y and gain X, the rate goes down. If it was, say, 1 over 4, it would now become 1 over 2 and continue to go downwards. So as you lose Y, the TMS reduces in value. Is that okay? Okay. Then our next point tells us that en dépit de cette substitution, la satisfaction reste la même à cause d'une compensation entre d'une part la perte de la variation de Y, it's here, unité, qui fait diminuer l'utilité totale des variations de Y fois utilité marginale de Y. So the basic thing that this part is saying is that even though you're losing Y and you're gaining X, the satisfaction will always remain the same, and that is because you are compensating. The more you gain Y, rather the more you lose Y, the more you gain X. So even though you're losing 1 or 2 of the other one, you're still gaining more, and so the satisfaction will still remain at the same level. It's just that you are gaining more of X and losing Y. And then it says, et d'autre part, le gain de variation de X unité de X fait augmenter l'utilité totale des variations de X fois utilité marginale de X. So this part here is another formula you see later as we go on. It tells us in this case that I mentioned previously that they will over time refer to total utility, like they'll mention it sometimes, but it's not the focus for this theory. But this formula here, that is the variation of X times the marginal utility of X, in this case is what will give you the total utility of X. So it's logical to think that if you are increasing the value of X, then generally the value of this entire formula will increase. And so if this formula gives you total utility, the total utility is going to increase. And in the same way, when you come back here to variation of Y times the marginal utility of Y, if Y is decreasing, it means that the entire value of this equation here would decrease. And if this formula is what gives you your total utility, then your total utility is also decreasing. Is that okay?
Yes, but you said to say when we're increasing Y, that means that we're also increasing the TMS. But what if we increase X? We mean that the TMS is also increasing, and if we're just increasing the marginal utility for X.
Come again? Let me just get that clearly.
To say if we increase Y for the value of Y, means that we're also increasing the TMS. what if we increase this one thing? Do it mean that we're increasing the TMS or we're just increasing the marginal utility?
Okay, so let me start with the second part of that question. When you are increasing the values of x, what you increase is the total utility of x, not the marginal utility. In this case, let's say that marginal utility is something that's constant. So it's already there. Say your UMX is 8, so it remain that way. But the fact that you are increasing the value of x, then you're increasing the number of quantities of x that you consume, will mean that your total utility will increase, because this would be a case where this formula, the complete formula is this ux. So what will be increasing is not your marginal utility, but your total utility. Marginal utility will be constant, but since x is increasing, the entire value of the result of this will increase, and so it means your total utility will increase. Let's say perhaps that this is 4, and then the value of x that you consume is 2. Voilà. That means your total utility will be 8. The 4 remains constant. Say now that you increase it to 4. What you would now have is total utility of, guess what's 4 times 4? 24. Okay. 16. It's okay, we have calculators for this. Have you guys ever had a situation where you're in an exam and you have to check what 2 plus 2 is just because you're not sure? We have come to that point. We have reached that point. Voila. So 4 times 4. We move. 4 times 4 is 16. So the general idea is that your marginal utility will remain constant, but your total utility will, rather your quantity consumed of x is what is increasing. And so what is increasing in this case is not the marginal utility, but the total utility. Is that part clear before I handle the first part of your question?
Yes, madam.
Okay. Shukran. So let me just put, this wasn't supposed to be there. Let's do this. Voila. Okay. Then the first part of your question, you asked that if we increase y, it means we are increasing the TMS. This is coming from the reasoning that if we are decreasing y, then we are decreasing the TMS. Am I with you so far? Is that what you're implying?
Yes.
Okay. Now the question is, if we increase our x, will the rate increase as well? Well, this is a question I never had myself when studying this, but I'd have to assume that yes, the TMS would increase, but because I am not certain on that point, I won't make that a certainty for you. I won't, because you might go and research and find that it's something different, so I don't want to tell you something that I'm not certain of. I would assume that would be the case, but I can't tell you certainly. You may have to go and research on that one for yourself. Is that okay?
Yes, it is. Thank you.
Alright, you're welcome. So, that's the general idea of this point. Is there anything I need to clarify? Should I go through this point again before we move forward? Or we're okay to go?
There are 1 minute remaining. I don't know if we'll go for a break or we'll continue until 12.
Let me analyze what we have to look at. Alright, so I think from here we can just continue and finish off because there isn't much. The next thing is just another. This part just shows us how we came to this equation. This one I already showed you, and then the last section shows us a different formula that has to do with marginal utility. So I think from here we can just continue, and yeah, then we'll end our lesson. This is the first time we've done a lesson of 2 hours, no? This is the first time. Okay. Yeah, so we'll just continue if that's fine with you guys, unless you want a break. Do you want a break?
No, it's fine.
Okay. Alright, so we'll continue, therefore, if there's no questions on this point. Now, so we have another equation here. This equation is telling us how exactly we came to this final point here. Was that a question, or are just going forward?
Yes, please.
You speaking. A repetition. Okay, sure. Alright. So let's come back. Let me try to summarize this point. This slide right here is just telling us that satisfaction remains the same even if you are losing a particular quantity of y and gaining a particular quantity of x. Now, in this case, we have this formula here. This new formula we have shows us how you come to total utility in this case. Let me just put this back. Ux. So the reasoning here is that if this formula that you have here gives you total utility, the fact that you are increasing the number of x that you get will directly mean that you increase your total utility as well. That's why I gave that example of if you had marginal utility of 4 and 2 as your value for x, you have 8. But then if you have 4 and 4 again, you have 16. It means that you are increasing the value of x and therefore increasing your total utility, even though marginal utility remains the same. In the same way, when you come here, the fact that you are decreasing the value of y that you have means that the total utility of y will also decrease. It's a case where you might interchange the same example that I gave you. You have 4 here and 4 here would give you 16. But if you had 4 as your marginal utility, then you had 2, so you reduce the value to 2, then you come to 8. So simply because you are decreasing your the value of y that you have, the total utility of y will also decrease, just following the formula that we have here. So like I said, for the practical part of this, we'll see it more as we go on. What I really want you to understand right now is just the theory behind it, the fact that you will be reducing the value of y that you have and increasing the value of x, but the utility or the satisfaction that you procure from this combination will still be the same. Is that okay? Okay. I will take the silence as a yes. You guys, are we sure we're together? This question was from Priscilla specifically. Priscilla, are you clear? Or is it okay for now? Okay. Silence. I guess we'll go on. So,
She said yes in the meeting chat.
okay. Thank you. Alright. Oh yeah, I think for the next lessons as we go on, if someone types something in the chat, those of you who are seeing, please be sure to notify me, because right now I can only see the PowerPoint. I can't really see the chat. So if someone asks something in the group or says something, make sure to notify me so I can answer any questions that are there, because I know that not everyone will speak, and that's okay. But if you interact in the chat, I can still respond to you. So just let me know when someone types something. Okay, so we have a new formula here for total utility. This is in a case where you're looking at the two goods. It's not just total utility of y or total utility of x, it's total utility of everything put together. So that would be the variation of total utility of x plus a variation of total utility of y is equal to total utility, which is also equal to 0. I cannot explain to you exactly how this formula came to be. I'd have to do my own research, but this is the current formula we have, and from this formula we came to have this at the bottom. It was just a case of changing places of values, twisting them around until they came to a particular conclusion, where you have the variation of x times marginal utility of x plus the variation of y times the marginal utility of y is equal to 0. Why is this? We saw this in the previous slide. For you to have the total utility of x, you multiply this and this. And for you to have the total utility of y, I don't know if I said y or x before, but of y, you have this and this. So, logically speaking, if you're saying we're going to add ux and uy, it means you're adding these two here. And therefore, you have this point. Variation of x times umx plus variation of y times umy is equal to 0, which again, it's equal to this, the same thing. Let me just put them together so you can see. Copy. And put this here. So what you can do is just take a screenshot of this particular part, and then you can see how the formula progresses for yourselves. Is that okay?
Yes.
And so this just explains how we came to our formula for TMS. And yeah, that's pretty much it. So just take a screenshot of this part. As we look at these issues more practically, we'll see the importance of them and how to apply them. Most of these things are usually easy when you learn to apply them. Our second last slide basically is just summarizing TMS. At the beginning, we mentioned that here we'll still be looking at the equalization of weighted marginal utilities, which is the second law of Gaussian, which is what we will look at in the last slide. But here we're being asked to consider the first law of Gaussian as well. So just keep this clear, the important one for this theory is the second law, but here we're also considering how the situation can work when we consider the first law. So it says, à la lumière de la loi de l'utilité marginale décroissante, UMX diminue quand X augmente et UMY augmente quand Y diminue. Basically telling us that in the same way that we learned, when you are increasing the values of X, your UMX will decrease. Or let's say the total utility. As your total utility is increasing, marginal utility will generally decrease. That's what we learned in the previous lessons. Yes? Are we together there? Guys, are we okay?
Yes.
Right. Okay, thank you. And in the same way, as the total utility of Y increases, the marginal utility of Y will decrease. So this is telling us that when we increase our X, our UMX will go down. And when we increase our Y, rather we increase our UMY, our Y will decrease. It's basically the same thing. It's basically telling that if you increase X, UMX decreases. If you decrease X, UMX increases. If you increase Y, UMY decreases. And if you decrease Y, UMY increases. And we'll see that practically. En d'autres termes, le consommateur accepte de plus en plus difficilement de séparer d'un bien qui se raréfie, Y, au profit d'un bien qui devient de plus en plus abondant, X. The same thing we looked at. The consumer is trying to see how much can I give away of Y for me to get more X. How much of this can I lose to get this? How much of this can I gain and lose this? Voilà. Le résultat, le TMS is XY décroît donc à mesure qu'on substitue X à Y. This is a point we mentioned previously, where we said that as you are losing Y, your TMS will be reducing. The same way that was mentioned, if you are increasing Y, then your TMS will generally increase. But the point we're focusing on right now is the fact that as you are decreasing the value you have of Y, your TMS will be going down, decreasing. And that's pretty much the entire theory behind TMS. Nothing more to look at. The next thing we have here is just another formula that's looking specifically at marginal utility. But otherwise, that part is done. Any need for clarifications there? Come again. The last part, this entire slide, or the last part in yellow? Okay. Excuse me. So, we came to this conclusion previously. It says résultat, the result being or resulting in the marginal rate of substitution, le TMS, decreases, therefore, à mesure qu'on substitue x à y. That's to say, the more you are losing y and gaining x, the more your TMS will decrease. We discussed this previously. Alright. You're welcome. So yeah, our last part. In the previous formula, we saw that they came to that formula because we were looking at two different points of the same indifference curve. And when we come back for the application in the next lesson, I'll show you what that means. But in this case, we're being asked to look at one particular point of the curve of indifference. That means you're looking at just one combination. It says un point d'une courbe d'indifférence continue relative à la fonction y est égal à f de x. Le terme xy est égal à l'opposé de la pointe de la tangente à la courbe en ce point. Now, this French was very hard for me to understand when I was studying this in my first semester. Basically, it's just telling us that when you're considering one point, you just be looking at the derivative of x and y in that case. Let's go back to the graph here. The point that they're talking about and that's being talked about in that last slide is the point E. We will discuss more. The point E has a lot of connotations. It's associated to a lot of different things, and we'll see that as we go on. But when you're considering one point, this point E, for you to find the value of your TMS, you're just deriving x and y. So here we have a negative dy dx, and this can also be associated to your marginal utility. So the actual formula that you use is this last one here. You won't have to pay much attention to this, just this point here. This point is also a little bit difficult for me to explain because it's very practical in nature and we'll just have to see it through calculations. But yeah, for the most part, not for the most part, this is the entire theory. This is all that you have to understand in this case. We'll make sure to go over the formulas themselves on their own. But yeah, otherwise, I believe we're done for this point. The important thing is for you to grasp the theory. Otherwise, if you don't get the theory, you may understand, not you may master the calculations, but if you don't get the theory, it won't make sense for you either way. You'll only be writing for the sake of exams. So yeah, that's it. Do you need any clarifications before we end our lesson?
Yes, on slide number 3.
Slide number 3. Voilà. Here. I don't know if you've moved away from your microphone. I can't get you.
Yes, there is also that line which looks like a tangent point. Is it a curve or it is also a curve?
No, it's a whole different line. This is what we call the revenue line, which we'll look at in the next section. It's not a curve. Okay. Okay. So apart from that, anything else? Okay, so if there's nothing else, I'm going to turn this into a PDF and I'll send it into the group for you to go over. One thing to note, where is this thing? Google Translate is always very helpful when studying. You would be surprised how many of your seniors still use Google Translate, even into the maybe second and third year, because French is something that it's not something you've been taking your whole life, so you always need clarification. So if you need to use, well, you will need to use Google Translate. Usually when I send you questions or when I send you notes, use it. It's very helpful. Another thing you could use is a different translator. It's more accurate. Let me just share my screen here. But yeah, using translators for most of your life as a student learning in French will be a necessity. You will need it for a good period of time. After a while, you won't need it, and there'll be a point where you stop thinking in English and you start thinking in French. But that day is not today, and so for as far as you need to use translators, they help you. Can you see this part of the screen?
Yes.
Okay. So you can use Google Translate. I have my Google Translate here, but I would recommend using DeepL. It's more accurate than Google Translate, and I used it a lot, usually for comptabilité, accounting, and for microeconomy specifically I used DeepL a lot, so it should help you as you go on. Otherwise, I believe we're done for today. Thank you for your presence, thank you for coming through, and thank you for your participation. You can always send me your questions in my DM. For those, I believe everyone has submitted their work, so I'll be going over it today. And yeah, so that's pretty much it. Thank you again. It's been a long time, but we'll
Yeah.
a bientôt. Oh, you guys are so cute using French. You should practice French a lot. Okay, so yeah, we're done. We'll meet next on Wednesday. Thank you again, and have a good rest of your day.